think it's about the right time. So I'm going to talk today about HTTP clients and Perl. Give you a little bit of background about myself. I'm a Perl consultant and I do a lot of work pulling in data feeds, sending it to the web. So I've been using a lot of various different services, writing clients for them. And today really I'm going to tell you a little bit about my experience about that. This is kind of the story that I have to tell. It's quite a long talk today, it's 50 minutes, so if at any point you're a bit confused or I'm not explaining something well, please stick your hand up and ask questions. Feel free to interrupt at any point because we've got a fair bit of time. So we're going to kind of follow this structure. I'm going to start out with the introduction and I'm going to talk about 4 main protocols that are important for the web, kind of working from the low layer up to the higher layer. I'm going to talk about 2 main Perl HTTP clients. These are the 2 popular libraries that people usually use for connecting to web services, for interacting with them. But there are also various other HTTP clients that I'll go into a little bit about. We'll go into some general advice, some things I've kind of picked up, some problems you might face when you're writing clients for web services. And I'll talk a little bit about how you test your code once you've written a client library. So that's kind of a summary of what the talk is going to consist of. So let's start by looking at the protocols. So we've got the lowest layer, the IP, the Internet Protocol, TCP, and then HTTP. There's also TLS and SSL, which kind of sits sort of between TCP and HTTP. But in terms of explanation, I'm going to go through it this order, because I think it helps build the understanding of the different layers on top of what's come before. So starting with IP. There are 2 versions of the Internet Protocol in use today. IPv4, which is commonly used, and IPv6, which is increasingly being used, especially by large service providers. If you talk to, say, either Google or Facebook's website or any web service of theirs, they support IPv6 now, as increasingly do more and more people. Both work, but IPv6 is newer, has learned from some of the mistakes of IPv4. The obvious big one is that it has a larger address space, but also it does various other things better. So I think as the years go on, we're going to see gradually more and more people move to IPv6. It hasn't happened to the extent that people thought it would, but we're getting there. And the low-level modules that support this, the web client libraries build on top of IO-socket-inet, which is IPv4 only. But recently they've started to also use IO-socket-IP if it's available. IO-socket-IP is in the Perl core as a Perl 520, but you can install it from cpan from earlier versions. And IO-socket-IP supports both IPv4 and IPv6. So HTTPTiny, which has been in Perl core since 5.18, also supports IO-socket-inet as of version 0.042. And NetHTTP, which LWP sits on top of, supports that as of 6.07. So you can start using IPv6 today. So we've got 2 versions, v4 and v6, but for the basics of this talk, I think you can roughly think of them the same. There are differences, but the idea is that they're packet-based communications technologies. If you've got an internet-connected device, computer, mobile phone, fridge, toaster, whatever, it's going to send data to a router. It doesn't really know how to send data to the internet by and large. The router deals with that. So your device just talks to the router, and it sends packets of data. So those packets, there's nothing clever about those packets. They're not an order. It doesn't reference previous ones. It just has a source address and a destination address in a header. There's some other stuff in the header as well, but again, for the purposes of simplification today, I'll just talk about that. And then it contains some data. So IP is basically just a whole bunch of packets being sent from a dumb internet host to a router, and then the routers all talk to each other and get it to the destination. And the internet routing is an interesting subject, but it's an interesting subject for another day. So sitting on top of IP, TCP gives us a bit more. IP doesn't have any set idea of connections. If IP packets get lost, well, they're gone. So TCP kind of keeps track of information, so it builds a layer on top such that you can have reliable communications between the 2 hosts that are communicating with each other. And the way this works is the client connects to the server by saying SYN, which is basically synchronize the connection. The server talks back SYN and ACK, and then the client says ACK, yeah, I acknowledge it. And this is basically the TCP handshake. The two machines set up the connection, and then they're ready to talk to each other without worrying about packet loss or data corruption or anything like this. So TCP is giving us the reliable thing on top. And so just as we've got IP packets, within the data of an IP packet sits a TCP packet. And the TCP packet also has a header and some data. And the header contains different things here. It contains a source and destination port. The port number for HTTP is port 80 or 443 for HTTPS. A sequence number which makes sure that TCP packets can get put back in the right order. And a bunch of flags. SYN and ACK are examples of the flags. Again, there's more stuff in the header, but this is kind of a useful summary for understanding how web clients are working. And then there's data, so the actual thing that we want to send in the TCP packet. Okay, so now basically internet protocols, most of them build on top of TCP. So there's HTTP, FTP, SMTP, blah, blah, blah. But what we're increasingly seeing on today's internet is that people are building services on top of HTTP. And so we call these web services. This is partly because HTTP has a whole bunch of useful things that we can use. Partly because corporate firewalls and all sorts of other things often lock down traffic that doesn't run over the web, so people just shove everything over the web so you can get around firewalls. And partly just because it's what we're moving towards. We're kind of moving up the layers of internet protocols. So what is HTTP? There are a bunch of internet standards, or RFCs as they're known, and these are the RFCs that define the core of HTTP. There are other RFCs as well that define various extensions. And these are all quite new. All these standards have come out this year. I mentioned RFC 2616 at the bottom of this slide. And a lot of the time when you hear people talk about HTTP or you're reading code, people will say, this section of RFC 2616 defines what we're doing. And that's fair enough because the newer standards have only come along this year. But what they do is they explain over a decade's experience of people using HTTP. They clarify some of the uncertainties and they define things where people have made mistakes. So if you are going to look at HTTP specifications, make sure you look at the newer ones because they're much better than 2616. So let's go into the details of how an HTTP connection works. Again, we've got the client. The client sends a request to the server, and the server sends a response back. So all nice simple stuff. And because this is sitting on top of TCP, we've got all the features that TCP gives us. So both requests and responses are instances of an HTTP message. And a message contains three things. The start line is the first line here, and then the header is the host and the user agent. Now this request doesn't have a body, it's just the start line and the header. But a response will typically have a body. A request can have a body as well, and a response doesn't have to have a body. But in the common case of just requesting something, the body comes back in response. And again, this response has a status line, the first line, then a bunch of header fields, date, content type, and whatever. And then the body. In this case, the body is some HTML. But nowadays, people are using HTTP for all sorts. So, of course, it could be HTML or an image on a web page. But it could be some JSON or a SOAP request or anything like this that people are sending over HTTP. And in HTTP's history, HTTP, it stands for the Hypertext Transfer Protocol. And it did grow up alongside HTML, the Hypertext Markup Language. So it was originally a way of delivering HTML pages. But as we've seen over time, people have used HTTP for all sorts of other things. So let's look at the status message. Here we've got the protocol, HTTP 1.1, which is the widely used HTTP protocol on the web today. It's very similar to HTTP 1.0, and the two are kind of backwards compatible to some extent. So a lot of, but HTTP 1.1 is what's typically used today. And then we've got 200, which is a status code here, and a textual description of the status code, and I'll come on to status codes in a minute. So there's the response again. Now, when you're dealing with these things at this low level, libraries like HTTPTiny and LWP have various methods that allow you to diagnose what's going on. So you can get the request and the response out, and you can investigate them And if you've encountered problems, you can see what's going wrong. But sometimes you might find that you're having trouble actually looking at these problems, and you might want to monitor the network itself. So on the machine you control that's running the client code, or that's running the server if you control the server, you can use two tools, TCP and Wireshark, and they basically capture the network traffic. And what I tend to do is I run TCP dump on the machine itself if I'm working with a server, because you don't need any graphical user interface. And I'll take the dump from TCP dump and load it in Wireshark. Wireshark's a graphical tool, it's really powerful, but I tend not to want to run graphical tools on a server, so I tend to use both for dealing with stuff. So that's kind of useful when you get stuck. So you'll hear the term REST a lot, and REST really is a codification of what HTTP was supposed to do. What we found when people started using HTTP for things that weren't just basic web pages, or as the web evolved, people were kind of misusing HTTP, and the status codes that I mentioned earlier, so 200 for success, people were just sending HTTP 200 responses for everything. It's not what the spec said, but REST started to codify some best practices around HTTP and started to define these verbs: get, post, put and delete. Here's the RFC that defined those. REST kind of codified those alongside URLs. So here's an example of a relative URL. You might want to get a city that's London. So that which would say, let's imagine we've got a web service which is all about cities in the world. That would fetch you the information about London. You might want to add a new city to your database, and post is the verb for creating a new thing. And in this case, you put your data in the request body. Put allows you to update an existing resource. So just we use the same address that we use get for, and we call a different verb put instead of get, and we can change that. And another verb is delete, if you want to remove an item from your collection. There are other HTTP methods, but I think for the purposes of writing web clients, these are probably the four most important ones. You know, people often talk about CRUD applications: create, retrieve, update, destroy, and get, post, put, and delete map to those. Now, I mentioned a bit ago about status codes and people checking HTTP status code 200. One thing you should be careful of when you check status codes is not to check the exact code you get, but to check the type of code. For example, if you want to say, did my request succeed, don't say, is the status code 200. Instead, say, does it start with a 2? Because you can get various things back from servers. And so these classes, we've got 2, 3, 4, and 5 are the ones you'll commonly encounter. And if you're using LWP, that has convenient wrapper methods for these. So it has is_success, is error. You can check the client's error or the server error. So it's worth using some kind of wrapper method or checking the type of status code there. So that's HTTP 1.1, which we're using today. In the future, which is sort of already here, is HTTP 2. There isn't an internet standard for HTTP 2 yet, but recent browsers will support it if you're running kind of a cutting-edge browser, and large web providers run it on their servers. Probably for most of us in this room, we're not going to use HTTP 2 yet. I suggest waiting till the standards have matured, till the implementations have matured. But if you are some huge web company, you can probably put a lot of work into using HTTP 2 and see some benefit of that. But for most of us, it's kind of early days, but it is coming there. So keep an eye on what's going on with that. So we've looked at the basic protocols for running web services, for talking to things. There's a small problem though. All this data that we're sending over the big, huge public internet, this wonderful, untrusted internet, is all totally unencrypted. And I think we've learned a little bit over the past couple of years that lots of people are looking at all this unencrypted internet traffic. So if you're sending anything even moderately sensitive, or even if it's not all that sensitive, it's worth encrypting your data. And TLS and SSL are protocols for that. In practice today, you use something called TLS. It's a newer protocol that updates SSL, but this is the way with names. The name SSL has stuck around. So really you shouldn't be running SSL today, but you'll still hear projects like OpenSSL, LibreSSL. But the protocol we're running today is TLS. And the URI schemes that we've got here, the one on the left, HTTP, is the unencrypted URI scheme that we use for old HTTP. And HTTPS is what we use when we're running over TLS. Now I should mention there's a small caveat here, that yes, TLS does give you cryptography, but it doesn't guarantee cryptography. There's various cipher schemes, so you can choose the right encryption protocol for your needs. And one of those encryption protocols is called none, which basically means you're running TLS with no encryption whatsoever. And you might think this is a bit crazy, but it's actually useful for debugging, because if you want to see data going backwards and forwards in the clear, you can use TLS, but with the none cipher. But you don't want to use it in production, just for debugging. Now, fortunately, most web servers and most web clients make reasonable choices about what ciphers they want to use, so you don't need to worry if, like me, you're not a cryptography expert. However, if you are running in an especially sensitive environment, it might be worth finding a cryptography expert, discussing your use case with them, discussing which cryptographic protocols you want to use on. Protocols isn't the right word. Which sort of cryptography you want to use on top of TLS. So again, let's talk a bit about the connection setup. When a client connects to the server, the first thing it says is, hello, start the handshake. The server then sends the certificates back to the client, because TLS is based around public-private keys and certificates. We'll come to that in a minute. Then they kind of discuss what sort of cryptography cipher they want to use. They kind of put a bit of randomness into the mix to help with the encryption. And then finally they switch to the cipher they want to use for the connection, and then the connection is set up. If you're using Perl, there are two common TLS implementations. I mention this because both HTTPTiny and LWP can use either of these. They both use the same approach. If IOSocket SSL is already loaded in your current process, they use that. If it isn't, but NetSSL is already loaded, they use that. If neither are already loaded, they'll try to load IOSocket SSL. If they can't load it because it's not installed, they'll use NetSSL. So the reason I mention this is if you are in a certain environment, you might find that your code works on one machine but not another. If that's the case, see which of these modules you've got installed. And if you want to guarantee what's going on, it's well worth in your application code loading one of these modules and not the other one, or just being aware that you can end up using a different implementation. I wouldn't say there's a best one, as is the way with Perl. There's more than one way to do it. They're just different. So I talked a bit about the public-private key mechanism that TLS uses for SSL. And the way that trust happens is you have a certificate. And a certificate is attached to a certain domain, and it's signed by a certificate authority. And the idea of certificate authorities is these are entities that you trust. And if you're using a web browser, it comes with a whole load of trusted authorities installed. Now, your idea of trust might differ from your browser vendors, and if you're using client libraries, you can customize which certificate authorities you do trust. You can even create your own certificate authority if you want. So to make sure that you're using the correct SSL certificate authorities, HTTPTiny, you will need to take the arguments on the bottom there. LWP user agent will need to take the SSL CA file argument. Also, if you are using LWP user agent, make sure you set verify hostname to 1, because otherwise it will just say, is there an SSL certificate? And it will trust that. However, that's before version 6.03. So when version 6.303 of LWP came out, a lot of people found that their web clients were breaking. And they were breaking because web services were using invalid certificates. Yes, it was a certificate, but it wasn't attached to the correct host. But if you're using old versions of LWP, make sure you set that flag to be more secure. So certificates are typically installed on the server, but you can use TLS certificates on the client side as well. And when you generate a certificate, you kind of follow this process. You generate your public-private keys on what's known as a certificate signing request, CSR. You send the CSR to the certification authority, this trusted organisation, and you can set those up for yourself. If you're building your own network, you can run your own CA. The CA then verifies the CSR, so it says, yes, does this host name look right, is it the right organisation? And they generate a certificate, and the certificate can be installed on the web server or the web client by the user. So that's kind of a quick overview of the various protocols that this stuff is sitting on top of. There's a lot more to get. So I've spent about 20 minutes describing these in the most brief way. I can think of, but there's a lot more to look into there if you're interested. So let's talk a bit about Perl's HTTP clients. I've already mentioned LWP User Agent, which is probably the most popular thing people use for speaking HTTP in Perl. It's been around forever, pretty much. Nearly 20 years. LWP was around about the same time as Perl 5. Perl 4 did have a previous implementation, which was quite different. So LWP that we use today was a rewrite for Perl 5. But again, going back to the HTTP being the hypertext transfer protocol. LWP dates from the days when web services didn't exist. It was a hypertext transfer protocol. And so LWP has evolved, but you will notice some kind of quirky things in there, and there's a few kind of gotchas that I'll come to in the general advice section of this talk. HTTPTiny is very much a minimal rewrite, a minimal implementation of HTTP. It ships in the Perl core, as I mentioned, as Perl 5.18. It's got very lightweight dependencies, but it has a lot of optional dependencies. So if you want to do neater stuff, you can install those optional dependencies. Although it's in the Perl core, I would suggest upgrading to the newer version, as with LWP, because both libraries contain bug fixes in more recent versions. As I mentioned, LWP is the most popular implementation, so it's the interface that people typically use. However, because LWP is implemented in Perl, it's been around for a long time. It has some quirks, a few bugs. LWP protocol net curl is an interesting thing, because what it does is it provides the same interface as LWP, but rather than using LWP's library code, it uses the C curl library. And curl is a command line tool, and the curl library, libcurl, is reused by all sorts of different languages, different systems, to provide a nice interface to HTTP. It's really well maintained, really good library. So basically this LWP protocol net curl kind of gives you the best of both worlds. A fast, reliable, robust C implementation of HTTP with the familiar interface of LWP that Perl developers are used to. I have to say, I haven't used this myself in production, but I know people who have, and I'm told, yes, it is a lot faster than HTTP, yes, it's really good, and, I trust the people who have told me this, so that's cool. So those are the two popular ones. Now, there are many, this is Perl, this is CPAN, there are many, many HTTP clients you can choose from, so if I haven't mentioned your favourite one, please don't feel bad. But there are lots of event loops on CPAN, and the advantage of event loops is that you can do lots of things at once, because of course HTTP is a networking protocol. You'll spend a lot of time in your code just waiting. So if you've got a standard procedural process, you'll send out a request, wait for a response, send out another request, and wait for a response. So event loops allow you to do multiple things together. Any events in Perl are the two popular ones in Perl. Mojo is also becoming more popular, and they all have asynchronous HTTP clients that you can use. HTTP async that I mentioned at the end here isn't strictly an event loop, but what it does is it kind of does some neat non-blocking stuff with LWP. So if you don't want to go down the whole route of using anything unfamiliar, anything very unfamiliar from LWP, you can use HTTP async, and it just wraps LWP, but does kind of allows you to process responses as they come in. It's quite neat. So, but yeah, my point here is if you are using an event loop, make sure you use the HTTP client supported by that event loop, because if you start using something like HTTPTiny or LWP, the whole non-blocking nature of your event loop is going to be lost when you're blocking on your HTTP connections, so be careful about that. The last one I'm going to mention, just because it's a bit different and a bit unusual, is Hike. This has a very different philosophy. Hike is not an HTTP implementation. What it is a really minimal subset of HTTP that lots of web services support. So it's really fast because it doesn't support all of HTTP. It's actually been benchmarked as being faster than Perl. So if you're running in a high volume environment and you want to write a web client that talks to a server that you control, and you know that server only uses a limited subset of HTTP, you can use Hike. And the Elasticsearch modules on CPAN build on top of Hike, because basically the idea is that the client then knows how the Elasticsearch server is going to respond. It's going to use this limited subset of HTTP, so we don't need the overhead of a full HTTP implementation. Now, of course, again, there are many, many, many more HTTP commands on CPAN, but that's to give you an idea of the variety of a few of the more popular or more interesting ones. And now I'd like to come on to some general advice when writing HTTP clients. One mistake that you see a lot when you're looking through CPAN code or other code is that people don't reuse their user agents. So what I'm doing here is I'm doing 2 GET requests with the same user agent. And the analogy I would use for your user agent, be it an LWP object or an HTTPTiny object or whatever, is think of it like a browser. You wouldn't start up a web browser, go to one page, shut down the browser, then start up the browser again and then go to another page. And likewise with your user agent, reuse your user agent that you already have, just because it's more efficient. So yeah, try to avoid creating lots of user agent objects and throwing them away again. You shouldn't need to do that. So if you're creating your own web service, you'll also want to not only reuse the object you're using, but let the user pass in their own object. Imagine I'm writing a large application that has lots and lots of client libraries that I'm using. If each of these instantiates its own LWP user agent, that's really wasteful. So make sure you let me pass in a user agent as an application developer if you're writing a client library. This is also really useful for testing, and I'll come to that later. But yeah, here's a bad example. The code here just builds its own LWP user agent and doesn't let the consumers override it, so avoid that. I started out by talking about how IP doesn't have the sense of connections, but TCP establishes connections. HTTP establishes connections on top of that. And then if you're using TLS, you've got the handshake of TLS. So one thing I found a few years ago, I was talking to a web service in the States from a machine in London, and the performance was really bad. Because every request I was doing by default was creating a new connection. So it was doing the TCP handshake, doing the TLS handshake. And HTTP as of version 1.1 adds a feature of persistent connections. So these are pretty much supported everywhere today. And what persistent connections allow you to do is to resend many requests over the same TCP connection. So you don't need to re-establish the whole TCP thing over again. HTTP2 has some even fancier stuff for dealing with this, but yeah, HTTP2 is not yet there yet. HTTP1 also has something called pipelining, but people have avoided pipelining because it's turned out not to work all that well, so HTTP2 goes on top of that. But what we do have is persistent connections, where you just set this connection and keep alive header. And you can enable these in both LWP and HTTPTiny. They're not enabled by default, but I would suggest if you're talking to a web service and you're going to send lots of requests and get lots of responses back, this will help improve your performance. So with LWP, you specify how many connections you want to keep cached. HTTPTiny is less sophisticated. You can only keep one connection open. But again, if you're talking to a web service, that's probably fine, because you're probably sending lots of requests to the same web service, getting lots of responses back. So yeah, that's well worth bearing in mind, particularly if you're talking to something on the other side of the world. Another thing that I find really useful but don't see especially widely used are URI templates. And these are a language agnostic thing. They don't come from Perl. The internet standard there, RFC 6570, defines them. There are implementations of URI templates in most programming languages. And they're a really nice way of building URIs. In Perl we have the URI library and other things, but templates basically use the curly brackets around parameters. And what I'm doing here is showing a very simple example of URI templates. They're actually a lot more powerful. You can put in query string arguments, you can have optional arguments, you can have things appear multiple times, but it's all using this curly bracket type syntax. So this is a really powerful way of building up URLs. You define your template, then you pass in some arguments, and that builds the URI for you like this. So yeah, if you are building a web service where you want to construct lots of URIs, go look at this module URI template. It makes life a lot easier, and it's not as widely used as it should be. So, just as I mentioned earlier about encryption, you want to run encryption. Another thing you want to do is to authenticate your users. If you're running a web service, you don't want anyone to do anything. And there are various ways that you can prove who you are to the web service you're connecting to. Probably the 3 most common ways are client certificates that I've already mentioned with TLS. It's not commonly used, but it's kind of neat because you can authenticate yourself outside of the HTTP layer. And then you can have the web server code, check it. HTTP authentication is probably the most common for web services. If you think about your web browser, HTTP authentication is basically when you kind of get the simple browser pop-up box and you type things into that. The only thing about HTTP authentication in your web browser is you can't log out of it. So in the early days of the web, people started using HTTP cookies, which were a way of maintaining state, to also support authentication. Using HTTP cookies within web services is less common, but it does still happen. So let's look a little bit at cookies, because imagine this is an HTTP header on one line. I've split it onto multiple lines for ease of showing you it on this slide. And the interesting thing about cookies is that they're set for a specific domain. So if you're the guy who owns example.com, you can basically set cookies for example.com, and then the user agent, if they're talking to example.com, will send the cookies back. Okay, so the top level domain here is .com, and we know that subdomains of .com are owned by lots of different people. But there's a bit of a problem, because imagine you're in the UK. Now, there's not someone who owns .co.uk. People own their own domains under .co.uk, such as example.co.uk. So we need to use different rules if we're dealing with cookies securely, depending on what the top level domain is. And there are a lot of top level domains nowadays. You can buy a .london domain, a .horse domain, as well as a .com domain that we've seen for years and years and years. And keeping track of this is difficult. But something came out of the Mozilla project that they were using in their Firefox web browser. There's what's called the public suffix thing. There's probably a better word for it than thing. But public suffixes, the idea is that it's something where anyone can have a subdomain of it. So example.co.uk, example.com are all public suffixes. And it's not just about the domain name ownership. Let's imagine you go set up a blog and you set it up under blogspot.com, your abc.blogspot.com, and someone else registers xyz.blogspot.com. Now, as far as the domain name service is concerned, blogspot.com, like example.com, is the domain that's been registered. But what Mozilla are doing with public suffix isn't just looking at kind of who owns domains, but they're looking for really popular things like blogspot.com, like livejournal.com, where each user has their own subdomain. And they're saying, well, actually, these you also want to treat these as independent, separate spaces. So public suffix is really useful. And the unfortunate thing is that most of the client libraries I've discussed for using cookies don't support public suffix by default. LWP's cookie support is really kind of ropey, because what it does is it just walks from the top level domain down, so you can set cookies for .co.uk with LWP and send them back. So if you are writing client code with an LWP user agent, make sure you either trust the servers you're talking to, or better still, install HTTP cookie jar. HTTP cookie jar supports both LWP and HTTPTiny, and it gives you more secure cookies by building on top of Mozilla's public suffix system. So yeah, while I continue with the general advice, perhaps back a bit, we talked a little about authentication. And HTTP authentication, like I say, is most commonly used. Basic authentication is, as it says, the most basic form. It's unencrypted, so you don't want to use it over plain HTTP. But if you're running over HTTPS, you pass a username and a password in, and the server deals with that. There's also digest authentication, which encrypts the data you're sending somewhat. And because HTTP authentication is extensible, systems like OAuth also hook into HTTP authentication. OAuth is really commonly used by a lot of web services today, because the idea is you don't need to know the username and the password to perform an action on behalf of the user. So if you're say, a Twitter client running on a web server somewhere, you can get the user can log in with OAuth, and you then get a token that represents that user, but you don't know the user's username and password. So that's how OAuth works. However, OAuth's really fiddly, and OAuth 2, the most commonly used version today, OAuth 1 is the older version, is one of those specifications where it says, well, here's the basic rule set, and then go implement stuff on top of it. So there are loads and loads of different approaches to OAuth 2. So if you find that you wrote an OAuth client last week and someone says, I need you to write another OAuth client, It's not great, I know OAuth, because you might find that they're doing it slightly differently. There are modules on CPAN that help with OAuth, some of which have OAuth in the name. JSON web tokens are commonly used with OAuth services, and there's a JWT module on CPAN. But my experience at the moment of using OAuth is that it's still fairly yucky. But it's a really good way of not needing to know a user's username and password, but being able to perform actions on their behalf, and still giving the user control over who performs actions on their behalf. So that's becoming increasingly used when you're writing web services, and you can integrate the HTTP authentication with your client library with OAuth. So skipping forward a bit. The last thing I want to talk about is testing your client. So let's imagine you've used LWP, HTTPTiny, whatever, and you've written a client and you want to test it. Now the best way to test it, of course, is to run your code against a real implementation of the real server that you want your code to run against, because that's when you see it running. However, you probably don't want to do automated testing, and as I mentioned earlier, you've got HTTP verbs like put, post, and delete, and yeah, going and trying testing to delete everything is a bad idea. And of course, if your code's buggy and you accidentally delete everything when you didn't want to, that can be a pain. And lots of web service providers offer sandbox environments, and when they do, that's great. Go use your service provider's sandbox. But often they don't. So what you can then do is basically capture a conversation with the production server. You could use TCP dump that I showed earlier, or you could use your client's built-in request and response monitoring facilities. Grab that conversation and basically write some code that your client talks to. And it's basically kind of an emulator. It mocks what would happen. So you look for a certain request, and when you see that request, you send a response back. It's a bit crude, but this means you can go and refactor your client code, you can add new things to it, and you can test whether you've broken it. And that's so basically you can start up an HTTP daemon for testing, and that's an approach that I've used quite a lot. If you're using LWP, Test LWP User Agent is a wonderful module, because what that does is it doesn't change the LWP User Agent module, but it provides the same interface as it. So earlier when I talked about client reuse, I said make sure that you let your users pass in a client object of their own. And that's really useful. If you're writing LWP code, in your test suite, you pass in a test LWP user agent object, and LWP, instead of talking to the network, ends up talking to this. And what test LWP user agent does is you define a bunch of rules for what you want your requests to match, and then you send back various responses. And the really neat thing about this is you can write little PSGI applications. And if you're familiar with PLAC and PSGI, you'll know that it's a really nice, simple protocol. All the popular web frameworks sit on top of it. But if you just want to do basic stuff, with PSGI, you take in a code ref, which is what you run, and you send back an array ref. The array ref is the HTTP status code, response headers, and the response body. So it's really easy to build up your own little test framework using Test LWP User Agent by writing a tiny kind of fake PSGI application. Then run your client code against this, and yeah, then you can check that your client code does what it should. So, it's quite a lot of stuff. I've actually got through this a lot quicker than I thought I was going to. I didn't get any questions, which I was really surprised. So, does anyone have any questions now? Yes, we've got one in the back.
Is there a way to do asynchronous database connections?
Okay, so this is very much an off-topic question, but that's fine. The question is there a module to allow you to do asynchronous database connections as there is asynchronous HTTP connections? And the answer is yes. It depends on which asynchronous framework you're using, but I know that any event and Mojo have them. I'm pretty sure Perl does. Someone going to nod at me and say yes, it does. So I think the answer is yes, but check given whichever event loop you're using. But certainly if you want to use an event loop, yeah, that's possible. Sure.
Yeah, here you say total finished. Does that mean that after the status code you can put any string you like, or is there some standard?
Yeah, you can. I mean, the status codes do have conventional names, and it's conventional to use those names. And I'm going to be really, really careful here because I'm talking in front of many people who probably know better than me read the specifications, check. But I'm pretty sure that the text that comes after the status code is kind of a convention and an advisory. But I could be wrong. To be honest, this is my idea of a bad joke, as you can probably guess. But yeah, any more questions?
HTTP2, I didn't know that existed. Can you give me a couple of bullet points?
Yeah, so HTTP2. HTTP2 is a really interesting protocol because HTTP is so widely used. It's been used for so many things. I think when people, HTTP 1.1 is pretty much backwards compatible to the web as it ran on Tim Berners-Lee's Next machine. You know, there's been no break in compatibility. HTTP 2.0, the one thing I should say is that it's still being discussed. It's very political because as everything, you know, let's say 15 years ago everyone built their new internet protocols on top of TCP or UDP. Nowadays, increasingly, we do see people building new internet protocols on top of HTTP, so it is kind of the kitchen sink internet protocol that's supposed to do everything. So there's a lot of pressure for people to ensure that cryptography always happens in HTTP2. I believe at the moment cryptography isn't mandatory because you don't want owners of really small websites to have to go and buy a certificate. But I believe Mozilla in their current HTTP2 implementation do mandate cryptography. So it's very much a work in progress. Another neat thing is we talked a little bit about IP packets and TCP packets. Now what you'll find with a lot of web requests in HTTP 1.1, particularly if you've got lots of cookies or lots of text going in the headers, is that they can fit into more than one packet. So one of the kind of background aims with HTTP2 was, can we fit all this stuff in one packet so the response can come back quicker? And the way they've dealt with that is by compressing and using a binary encoding format for the protocol. So HTTP 1.1 is all text-based, which means it's really easy to diagnose as a human being. HTTP 2.2, and this has been very contentious, does away with, makes it harder to trace as a human being. But the argument there is that this is a protocol for high-volume systems, for people who will build tools around tracing it. So kind of the reason I glossed over it in the main body of my talk is it's interesting, but I think it's too early for us to really know where it's going to go yet. But I hope that's a helpful summary of what I'm saying.
What advice would you give for microcomputers and HTTP clients? I mean, the file has its weak CPU, so it should be small and fast. Okay,
so the question was, what advice would I give for microcomputers and HTTP? What do you mean by microcomputers?
Like system-on-chip computers. Raspberry Pi.
Okay, so kind of low specification systems. Well, I think the first thing to go for here is to look at the example of, say, Hike. If you're talking to a server you know, you don't need a fully blown HTTP implementation. The other thing, of course, is libperl being written in C has a much lower footprint. I hate to say it, but if you're going really, really embedded, maybe don't use Perl. Although, of course, embedded systems are getting more and more powerful. You know, I was talking in the pub last night with Max, you know, a lot of embedded systems now are 64-bit. You know, your next phone is going to be 64-bit. So yeah, arguably do use Perl. But I think my advice would be the usual, download in modules you don't need. Does anyone else have any good advice for this? I don't know. I think, yeah, it's weird because embedded systems are becoming far more powerful than the computers we used as web clients and web servers 20 years ago. So, yeah, it's impressive stuff. Another question?
Yeah, do you know any, we know browsers, sometimes they get security issues where, you could know a resource from the big bad internet and do bad things on your machine. Is there such examples with libraries, with client libraries?
So the question is, browsers have security vulnerabilities, and obviously browser vendors are very quick to catch up with that, given the way that organised criminals are attacking end users' browsers to exploit information. And yes, it's software, it has bugs. I think LWP for me is perhaps particularly concerning for security. It's a really good library, but there's a lot of code in there. It supports lots more protocols than just HTTP. So, if you are, I've mentioned kind of the cookie issues with HTTP. I mean, I'm not a security expert, but I bet if you were to go and look at LWP, you would find issues in there. I think with the smaller implementations, less so. But of course, yeah, all software will have bugs, and I guess it comes back to the classic responsible disclosure. If you do find a problem with one of these modules, talk to the author in private rather than filing a public RT ticket that everyone can see. Or if you do find security vulnerabilities, always make an effort to contact the software's author in private first, because otherwise people will be scared off releasing their lovely code as open source, which we don't want. Do we have any more questions? Yeah.
Would you be able to make these slides available?
Would I be able to make these slides available? Yes, I will. So this talk is already, or a smaller version of this talk that I gave at YAPC this year is already on YouTube. It may be that the slides are quite well presented on that talk. I guess this talk may well find its way online as well. Sometimes I'm kind of in two minds about putting slides up, because I think slides on their own can be a bit confusing if you don't hear the speaker talking. But if I don't put them online, I'm happy to send my slides to individuals if you would get in touch with me. But anyway, I'm going to be around for the rest of the day. I'm going to be in the pub this evening. I'll be at lunch. If you have any more questions or just want to natter about stuff, please come and see me. Enjoy the coffee break. Thank you.